Good day, everyone. I would like to share to you our topic about sedimentary rocks. So let's start. Sedimentary rocks are also called secondary rocks. This group includes a wide variety of rocks formed by accumulation, compaction, and consolidation of sediments. Sedimentary rocks contributes about 8% of total volume of grass. Next slide. Formation of sedimentary rocks. The process of formation of sedimentary rocks is a very prevalent. Sedimentary rocks are formed at or near the, the Earth's surface by accumulation and lithification of fragments of existing rocks or by precipitation formed from solution at normal surface temperature. Forming sedimentary rocks. First is sediments, suspended in the water settling and disposition. Sediments is a solid material that is removed and disposed in a new location. Sediment can consist of rock and materials, as well as the remaining of plants and animals. It can be as small as a grain of sand or as large as a boulder. Sediments move from one space to another through process of erosion. Second, compaction. Settled, settled sediments, water and air squeeze out, grains press close together. Compaction is what happens when something is crushed or compressed. In many space, garbage undergoes compaction after it's collected. So it is it takes less space. The process of making sediments more compact or dense and very thickly packed together is compaction. The third one is sedimentation. Particles cemented or glued together. Sediments change to a rock. So cementation is geology. Sedimentation in geology, hardening and welding of plastic sediments. Those form from free existing rock fragments by the precipitation of material matter in the pure space. It is the last stage in formation of sedimentary rocks. Textures. Number 1. Origin of grains. A sedimentary rocks may be partially or wholly composed of clastic or allogenic grains or of chemically formed or organically contribute parts. Those the rocks may show a clastic texture or a non-clastic texture. Number 2. Size of grains. The grain size in sedimentary rocks varies with wide limits. Individual grains of less than 0.002 mm and more than 250 mm may form a part or whole of these rocks. Third, third three texture recognized on the basis of grain size are coarse grained rocks, average grain size 5 mm, medium grained rocks, average grain size between 5 and 1 mm, fine grained rocks, average grain size 1 mm. So grain size is determined of singular sediment grains or the particles in clastic rocks. The term may apply to another granul, granular materials to these deep dipplers form the size of crystallite, which refers to the size of a single crystal within a particle or grain. Many crystals can compose of a single grain. Number 3. Shape of grains. The sediments make the rock may be of various shape, rounded, sub-rounded, angular, and subangular. They may show ferocity to various degree. Rounded, roundness and ferocity are the indication of varying degree of transfer and abrasion suffered during that process. Those breccia are made up mostly of rough and angular fragments indicating less transport and abrasion. Conglomerates are full of rounded and soft surface pebbles and gravels, indicating lots of transport and rubbing action during their transport before getting disposed and consolidated into a rock mass. Number 4. Packing of grains. Sedimentary rocks may be open packed or porous in texture or tensely packed, depending upon their environment of formation. The degree of packing is generally related to the load of the overlaying sediments during the process of deposition. Number 5. Fabric of grains. A given, a given sedimentary rock may contain a many elongate particle. Their orientation is studied and described in terms of orientation of their long axis. If all or most of the elongated particles are arranged in such a way that their longer axes lie in the same general direction, the rock is said to show a high degree of preferred orientation. This direction is generally indicative of the direction of flow of the certain during the period of deposition. Number 6. Crystallization trend. In sedimentary rocks, a chemical origin in the texture is generally defined by the degree and nature of crystallized grains. Rocks may show perfectly interlocking grains, giving rise to crystalline, granular texture, or they may be made up of non-crystalline, colloidal, particles when they are termed as amorphous. Next slide is important sedimentary rocks. Number 1, breccia. It is a mechanically formed sedimentary rock classed as rudate. Rudate. It consists of angular fragments of heterogeneous composition embedded in a fine matrix of clay material. The fragments making breccia are greater than 2 mm average diameter, but sometimes this may be quite big in dimension. Quite big in dimension. Types of breccia are commonly recognized. Number 1, basal breccia. The name basal breccia, originally introduced for rock in the Azuzara impact structure, refers to the fact that peculiar this fecular breccia is regularly found at the base of the fosse impact, tectonically undisturbed upper tertiary. Number 2, fault breccia. Fault breccia or tectonic breccia is a breccia that was formed by tectonic force. Fault breccia is a tectonite formed by colonized zone brittle deformation, a fault zone in a rock. Number 2, conglomerates. These are the sedimentary rocks of clastic nature and also belong to Rhodaceous group. They consist mostly of rounded fragments of various size but generally above 2 mm cemented together in a clay or ferruginous or mixed matrix. The roundness of gravels making the rock is a useful characteristic to differentiate it from breccia, in which the fragments are essentially two types of conglomerates. Number 1, basal conglomerates, a conglomerates that resting on the surface of erosion and consequently making an unconformably form the bottom member of a sedimentary series. Number 2, glacial conglomerates. A glacial conglomerates carries a lot of coarse grained material and many glacier deposits, or are conglomeratic. The, the sediments deposited directly by a glacier are typical poorly sorted matrix supported conglomerates. The matrix is generally fine grained, consisting of final milled rock fragments. Number 3, sandstone. Sandstones are mechanically formed sedimentary rocks of arenaceous group. These are mostly composed of sand-grade particles that have been compacted and consolidated together in the form of beads in basins of sedimentation. Next slide. Composition. Quartz, close and open parenthesis, SiO2 is the most common mineral make, making of sandstone. In impact, some varieties of sandstone are made up entirely of quartz. Beside quartz mineral like feldspars, mecas, garnet, and magnetite may also be found in a small proportion in many sandstone composition. Next slide. Texture. Sandstones are generally medium to fine grained in texture. The component grains show a great variation in the size, shape, and arrangement in different varieties. Color. Sandstone natural occur in the variety of colors red, brown, gray, and white being the most common colors. The colors of sandstones depend on its composition, especially nature of the cementation materials. Types of sandstones. First is siliceous sandstone. Next is calcareous sandstone and argillaceous sandstone and ferruginous sandstone, archeous and greyrock. Next, flagstone. Last one is freestone. Number 5, limestones. These are the most common sedimentary rock form, the non-clastic group, and are composed chiefly of carbonate of calcium with subordinate proportion of carbonate of magnesium. They are formed both biochemically and mechanically. Composition of limestone. Pure limestone is invariably made up of mineral calciate, Ca and CO3, or shall we say calcium and carbonate. In terms of chemical composition, limestones are chief made of CaO and CO2. Magnesium oxide is a common impurity in most limestone. In some, its percentage may exceed 2%. The rock is then called magnesian limestone. Next, types of limestone. Chalk, types of limestone. First is chalk, second is schist limestone, and third argillaceous limestone, and fourth lithographic limestone, and last canra. Ah, Cancar. Sorry. Cancar. Next.
So let's start number 6, metamorphic rocks. So metamorphic rocks are defined as those rocks which have formed through the operation of stress minerals, various types of metamorphic processes on the pre-existing igneous and sedimentary rocks involving changes in textures, structures, and mineralogical composition. Ang mga metamorphic rock ay dating igneous o sedimentary rock ngunit nabago ito. Tinawag na metamorphous bilang resulta ng matinding init at pressure sa loob ng crust o layer ng earth. Ang mga ito ay malakristal at kadalasang may foliated o banded na textures. So, mineralogical composition. A. Stress minerals. The minerals which are produced in the metamorphic rocks chiefly under the stress factor are known as stress minerals. Ang mga metamorphic rock ay nagbubunga ng maraming kaakit-akit na mineral tulad ng garnet, corundum. Mga iba't iba pa nito ay kinabibilangan ng sapphire at ruby kyanite. B. These are metamorphic minerals produced primarily under the influence of temperature factor. Ang salitang metamorphic ay nagmula sa Greek at nangangahulugang to change form, at mga batong ito ay orihinal na igneous at sedimentary rock na binago ng init at pressure. Important metamorphic rocks. Number 1. Schists. Schists are megascopically crystalline, foliated metamorphic rocks characterized by a typical schistose structure. The constituent flaky and plative minerals are mostly arranged in parallel or subparallel layers or bands. Ang schist ay isang medium-grained metamorphic rock na nagpapakita ng binibigkas na schistosity. Nangangahulugang ang bato ay binubuo ng mga butil ng mineral na makita gamit ang isang power hand lens na nakatuon sa paraan na ang bato ay madaling nahati sa manipis na mga natuklap o plates. Textures and structures. Most varieties are coarsely crystalline in texture and exhibit a typical schistose structure. Karamihan sa mga varieties ay magaspang na malakristal sa textures at nagpapakita ng typical na struktura ng schistose. Quite a few types show lineation and porphyroblastic. Ilang uri na nagpapakita ng lineation at porphyroblastic. Yan po. So, composition. Gneisses are generally rich in the minerals of parent rock that are simply recrystallized during the process of metamorphism. Feldspar and quartz are more common in gneiss than in schist. Dark minerals of pyroxene and amphibold groups are also common, as are the typical metamorphic minerals like staurolite, sillimanite, gamete, kyanite, and epidote, etc. Karamihan sa mga schist ay binubuo ng mga platinum mineral tulad ng muscovite, turite, tail, sincite, biotite, at graphite. Ang feldspar at quartz ay mas kaunting sagana sa skis kaysa sa gneiss. So, number 2, gneiss. Gneiss is a megascopically crystalline, foliated metamorphic rock characterized by segregation of constituent minerals into layers or bands of contrasting color, texture, and composition. A typical gneiss will show bands of micaceous minerals alternating with bands of equidimensional minerals like feldspar, quartz, and garnet, etc. Isang ori ng metamorphic rock na may natatanging banding nakikita sa hand specimen o sa isang microscopic scale. Karaniwang nakikita ang gneiss sa skis sa pamamagitan ng foliation at schisticity nito. So, texture and structure ng gneiss. Gneiss show a variety of texture and structures, the most common being coarsely crystalline textures and the gneiss structure. Ogen's gneisses show a typical protoclastic structure in which the hard minerals are flattened and elongated. So, ito yung texture and structure ng gneiss. So, number 3, quartzite. Quartzites are granular metamorphic rocks composed chiefly or of interstructured grains of quartz. The name orthoquartzite is used for a sedimentary rock of similar composition but having a different sedimentary origin, in which quartz grains are cemented together by siliceous cement. Sandstone na na-convert sa isang solid quartz rock. Hindi tulad ng mga sandstone, ang mga quartzite ay walang mga pares at may makinis na bale. So, composition. Beside quartz, the rock generally contains subordinate amounts of micas, feldspar, garnet, and some amphiboles which result from the recrystallization of some impurities of the original sandstone during the process of metamorphism. So, ang quartzite ay halos ganap na binubuo ng silicon dioxide. Kung ang kadalisayan ay tungkol sa silicon dioxide, ang bato ay tawag na quartzite. Kung hindi, ang quartzite ay karaniwang naglalaman ng iron oxide. At maraming may iba't ibang halaga pa ng mineral na rutile, xyron, at magnetite. So, yun. So, origin and uses. Origin. Metamorphic quartzite result from the recrystallization of rather pure sandstone under the influence of contact and dynamic metamorphism. Yan. So, yan yung origin ng quartzite. So, ang uses ng quartzites. The rock is generally very strong, dense, and uniformly grained. And it finds extensive use in building and road construction. Yan. Yun po yung uses ng quartzite. So, number 4, marble. Marble is essentially a granular metamorphic rock composed chiefly of recrystallized limestone made of mineral calcite. It is characterized by a granulose texture, but the grain size show considerable variation and different varieties. So, ang marble ay butil-butil na limestone o dolomite rock na binubuo ng calcium, magnesium, or carbonate na recrystallize sa ilalim ng impluwensya ng init. at may tubig na mga solusyon sa commercial. Kabilang dito ang lahat ng pampalamuti na mayaman sa calcium ng mga bato na maaaring puliduhin. Gayon din ang ilang particular na serpentine bird antiques. So, yan po ang marble. Then, composition. Small amount of many other granular minerals like olivine, serpentine, garnet, and some pebbles are also present in many varieties which are derived from the impurities present in the original limestone during the process of metamorphic recrystallization. So, ang marble ay pangunahing binubuo ng calcite, dolomite o maraming serpentine. Ang chemical na composition ng marble ay binubuo ng mga pangunahing sangkap. So, ito yung origin and uses ng marble. Marble is formed from contact metamorphism of carbonate groups of sedimentary rocks. So, yan po yung origin. Sa uses, marble is commonly used in the construction of palatial and monumental buildings in the form of blocks, slabs, arcs, and in the crush form as chief for flooring. Because of its restricted occurrence and transport costs, it is mostly used as ornamental stone in costly construction. So, yun po yung uses niya ng marble. So, number 5, slate. Slate is an extremely fine grain metamorphic rock characterized by a slate cleavage by virtue of which it can be readily split into then sheets having parallel smooth surface. So, slate, isang napakapinong butil na metamorphic store. So, nailalarawan sa pamamagitan ng isang estado ng cleavage na nahati sa manipis na mga sheets na may makatulad ng makinis na ibabaw. So, yun po yung slate. So, origin, slate is a product of low-grade regional metamorphism of argillaceous rock, like clays and shells. Such metamorphic rocks with conspicuous micaceous constituent and general slaty appearance are termed pyrelites. So, yun pa yung origin. Then, uses. Slate is used locally where available for construction purpose as a roofing and paving material only. So, yun po yung uses ng slate. So, hanggang dito na lang po. So, maraming salamat. Bye-bye.